The aim of this tutorial is to help you with the discriminant, and the discriminant, just to remind you, is b squared minus 4ac. And you've got three possibilities for the discriminant. If it's greater than 0, it means there's two real roots. If it equals 0, that means there's one real root. And if it's less than 0, that means there's no real roots. So in this question here, you have got to find what values of k will give this quadratic equation real roots. So that means it could be one real root or it could be two real roots, which means that we've got to show that b squared minus 4ac is greater than or equal to 0. So we can look at well, let's find the values of a, b and c. So a is going to be whatever's before the x squared, the coefficient of the x squared. B is whatever's before the x. Now you have to be careful here because you just think it's that little bit there, but it's actually the minus as well. So it's going to be minus 3k minus 2. And c is just whatever's left over, and that is just 2k. So we're going to put these values into the discriminant, and then we'll probably end up with a quadratic equation which we have, or quadratic inequality which we have to try and solve. So first of all, b squared minus 3k minus 2. And again, this is where you've got to be so careful with negatives here, because if you replace the b with this and square it, all of it has been squared, and this, by writing like this, only the brackets has been squared, so you're going to have to put an extra brackets around that to show that you're squaring the minus as well. And then we're going to take away 4 times, now a is the value k minus 2, so again pop that in brackets. And then we're going to multiply that again by c, and c is 2k. And we've got to solve this and work out when about that is greater than or equal to 0. Right, so let's start multiplying out these brackets. First of all, a minus squared is a positive, so that minus is now being moved to positive. Let's square out this bracket here. I do 3k all squared, that's going to give you 9k squared. I multiply this times this, and that gives you minus 6k, and then I double it, give me minus 12k. And then minus 2 all squared is plus 4. And then the next part, I'm going to do 4 times 2k is going to give you minus 8. And I'm not going to multiply the brackets yet, I'll do that in the next line. Just do one bit at a time there. So I've just done the 4, I could have done 4 times this brackets first, but I thought I'd multiply these two terms together first, and then I'll multiply what's in the brackets. So next line, so that remains the same. We multiply these brackets, we get minus 8k squared, and again you've got to be always very careful with the minuses here, because you're not doing 8k times 2, you're doing minus 8k times a minus 2, which would be a plus 16k. And if we just collect the like terms now, we've got 9k squared minus 8k squared, so it's going to be k squared. That, add on to that, will give you plus 4k, and that will give you plus 4. So that's the inequality that we've got to try and solve. And now to solve a quadratic inequality, you can't just you can't do that in your head. You've got to draw a little graph of it. You've got to draw a graph of this quadratic function, just a quick one. And then once you've drawn that graph, you'll be able to work out when about it is greater than or equal to 0. So to draw a graph of this, what we want to look for is the roots. So let's work out what the roots are of k squared plus 4k plus 4. And the roots exist when it's equal to 0. So we can factorize that, x plus 2, and then, oh, not x, it should be k plus 2, and also k plus 2 here. So that means both the roots occur when k equals minus 2. So we're going to draw a graph of that. And again, this graph is just a sketch, doesn't need to be anything special. We know we've got it touches the x-axis when k is minus 2. So in this case it wouldn't actually be the x-axis, it would be the k-axis. And we also know, because this is a k squared here, it's going to be a happy face, which means it's going to be a minimum quadratic function like that. And from this you can see that for whatever values of k you put in, it will always be above the k-axis, always be above this axis here, which means it doesn't matter what value you put in, you'll always get real roots for this quadratic up here. So if you put any values into here, any value of k, you'll always get a real root. If you put in, when k is minus 2, when it actually touches exactly along on this line here, that means you'll only get one real root. But it doesn't come below the axes, which means at no point will there be no real roots. So that means you can say it does not matter what value of k is used, because they're always real roots. And you can write that a little bit neater. You can say, you can use this little symbol here: for all values of k you will get real answers. And that is how you can answer that question. I hope that helps.